Hello everyone, this video is going to be the first video in a series of videos on derivatives. In this video, we'll look at the basic rules involving exponents, logarithms, and constants. In the other videos, which I will have linked in the description below, I will explain how to solve more complex derivative problems such as chain rule, quotient rule, product rule, and the likes. Alright, so we're going to start off looking at the basic rules of derivative, and in this case, we're going to look at the exponent and the logarithmic rule, okay? And so in our first example, you have e raised to the power of x, and so to take the derivative of that, it's simply going to be the exact same thing, e raised to the power of x. And so keep in mind that when you take in the derivative of e raised to a variable, the derivative of that is going to be the exact same thing, whatever it is. And also notice the symbol for writing the derivative. You have just a simple apostrophe in between, and that's it. So now let's look at another example. Here you have 4 times e raised to the power of a. And like I said, the derivative is going to be the same thing, so you have e to the power of a. However, in this case, you have a constant, and all you have to do is just multiply that constant, and you have the exact same thing once again. So as you can see, the exponent rule is quite straightforward. It's not uncomplicated. So now let's look at the logarithm rule. Here you have the natural log of a variable, and in this case you have the natural log of x. And so to write the derivative of that is simply going to be 1 divided by the variable, which is x. So similar to the exponent rule, it's also quite straightforward in a sense that whenever you have the natural log of a variable, it's just going to be 1 divided by that variable. And let's look at another example. Here you have the natural log of m times 3. And so how would you take the derivative of that? Well, simply 1 divided by him. But in this case, you have the constants, and we're going to treat it like we did in the case of number 2 up here with the exponents. You just simply multiply the derivative by the constant, which is 3 times 1 divided by m. And when you want to simplify that, it's going to be 3 times 1, which is 3 divided by m. And that's really all there is to it. So now we're going to look at the exponents rule when the base is not e, because previously we looked at the exponent rule when the base was e, and there are cases where the base is not e, like we see here, where we have a base of b. And so how would you find the derivative of this? Well, it's going to be this very similar to what we did before with the base of e, whereby you would still write the same thing for the derivative. However, you would have one additional step of having to multiply by the natural log of the base, which is b, as you can see. And so this is still fairly straightforward. You just have one additional step of doing that. And so let's look at another example. Here you have the base of 4, and so you have 4 to the power of x. And to find the derivative of that, you would simply say 4 to the power of x is the derivative, but multiply by the natural log of 4, because 4 is the base. And when you simplify that, you know, the natural log of 4 is going to be approximately 1.39, and so you would multiply that by the 4x, and that's how you would find the derivative of 4 to the power of x. Now we're going to look at the other logarithms, because before we looked at natural log, and we also have opportunity to take the derivative of other logarithms like log base 10 and all that. So let's look at some examples. Here you have log base b of x, and to find this kind of to find the derivative of this, it's quite similar to the natural log, whereby you're still going to be taking 1 divided by the variable. However, similar to the example above, you're going to be multiplying by the natural log of the base. And in this case, the base is b, so it's going to be a 1 divided by x times the natural log of b. And now let's look at another example. In this example, we have log base 4 of x. And so to find the derivative of this, you would simply say 1 divided by the variable, which is x, and you're going to multiply that by the natural log of the base, which is 4. And so when you go to simplify that, we have 1 divided by 1.39, because like we said above, the natural log of 4 is approximately 1.39. And then we just bring the x to the back here, and you can leave the x in front if you want, but to make it neater, we would put the x right here. So let's look at one more example. Here you have 3 times log base 3 of b, and so to find the derivative of that, you would say 1 divided by the variable again, which is b, multiplied by the natural log of the base, which is 3, as you can see right here. And then also remember we have the constant. So remember when we took the natural log, we said if we have a constant in front of it, you would, when you take the derivative of that, you would simply multiply by the constant. And so you have 3 times 1 here, and the natural log of 3 is 1.10, approximately 1.10. And again, we bring the b to the end, but again, you can leave it in front if you want. And so to simplify all of that, it's 3 times 1, which is 3, divided by 1.10b. And so that's all there is to it. Now we're going to look at the last part in our derivative basic rules, which is a constant rule, and this is literally the easiest out of all the basic rules. Whenever you have a constant by itself without any variable or anything else, the derivative of that is always going to be 0. And so let's look at some examples just so you see what I'm talking about. Like you can see in this first example, you have 3, and the derivative of that is going to be 0. And even in the second example where you have 4, the derivative of that is also 0. So that's all there is to it. Thanks for watching this video. If you have any questions, feel free to leave them in the comments down below. Like and subscribe if you want, as well as share the video with anyone you think might find it helpful.